So this is a short video just looking at the reason we do normalization in the first place. So in my previous video, I've already explained what some of the terms are. So primary keys, foreign keys, and the idea that we can have two different entities or two different tables, and we can link them together using foreign keys, and we have those relationships between them, which basically allow us to kind of enable the relational part of relational databases. So in this example, consider order 2. So in customer 1, you can see that we have got 3 orders. So customer 1 has made 3 orders. Okay, now that's got aggregate data inside it. So it's got 3 separate bits of information inside a single cell. And those orders are frisbee, t-shirt, and another frisbee. And you can see the product IDs are there as well. So we have lots of information. So imagine Bob decides to cancel order 2 and we need to remove it from the database. Now, how would we do that? Now, the answer is actually not as straightforward as you think. Well, can I just take it out? Job done. Well, no, I can't actually, because in order to do it, I need to ensure that these are in the right order. So what if order 2 was actually not the frisbee, sorry, the t-shirt, maybe it was the second frisbee that they wanted. Okay, so these have to be in the right order. Now, if that's the case, then I'm going to have to use string manipulation. So think back to your programming when you're looking at substrings. So I'm going to have to use that. I'm going to have to find where the commas are, take that value out, put them back together again. Well, that's a computationally complicated process. It's not a simple thing to do. And then I have to search for it in the first place. Okay, so I have to search for that order 2, then I have to go to search through, find the second thing, because I can't just simply go to the first comma and remove it. I have to actually find the right one. It's not a simple process. And when something's not simple, there's that chance for it to go wrong. And therein lies the problem with this table. So aggregate data is a really, really bad idea for those kind of ideas. So this table has not been normalized. We say it's unnormalized, or UNF, unnormalized normal form. So we need to improve that. So the purpose of normalization is threefold. Now the first one is to eliminate data redundancy, to reduce, eliminate, update and delete anomalies, and finally to protect data consistency. Now let's go through those 3 ideas, what they actually mean and why it is so important. Data redundancy is a big problem for a database. Now remember that any single piece of information has to be stored, doesn't it? Okay, so a single string, it might take a few bytes up, but if you start thinking about all the rest of the information inside that record, those few bytes might be a few kilobytes. Now that in itself might not be a big deal, but when we're dealing with real databases, when we have millions and millions and millions of records, a few kilobytes actually times by a million makes a big difference. So any form of data redundancy is a problem. It's not efficient. And in computer science, efficiency is all about space and time complexity, isn't it? Okay, so think about the more data I have to sift through when I'm searching, the longer it's going to take. Okay, that's just the way it is. No matter how efficient our algorithms are, that is always going to be a problem. So the more data, the longer it's going to take. Okay, now databases are very efficient creations, but they all computer science are kind of based on those rules. Okay, but you can't get away from them. Secondly, they can take up a lot of storage space. Okay, so not only are we going to use up a lot of storage space, additionally, if we have redundant data, we're also going to use up more processing time in order to find the data. So data redundancy is bad for a database, for real life databases. Now, if I have the same data in database twice, that's unnecessary, isn't it? Surely I should only have it in there once. Now, data redundancy has an issue with efficiency and space and CPU time, but it also has other knock-on. And this is update and delete anomalies. Now, this becomes a bigger problem. So if I've got Bob in my database twice, okay, you can see here I've got Bob twice, and Bob's moved house. Okay, so he's moved house. And he's moved to B90. Okay. Unfortunately, if I have Bob in my database twice with his address in there twice, if I only change one of those records, then I have the problem that we have two addresses stored for Bob. Okay, so I now have B87 and B90. Now if I did a search for Bob, okay, and I found the first record, so this one here, when actually, and I maybe sent his DVD or item or product to that old address, well, he's not going to get it, is it? And some lucky person's going to get a free DVD or whatever it happens to be, which is bad, obviously. So update anomalies is where we've updated a record, but because there are multiple duplicate data in there, we only change one of them, we have inconsistency between the two records. The same happens with deletes. Let's say Bob decides to remove himself from this database for whatever reason, but only delete one of the records. So maybe I delete the first record here, so that goes away. Bye bye record. I didn't actually mean to rub that second one out, so I'm going to just get rid of that. Do that one again. So imagine I'm going to carefully rub out the first Bob. I'm using a trackpad, by the way, which is why this isn't as streamlined, as smooth as it probably could be. My mouse had broken. Wonderful. Anyway, not important. So the first one's been removed, and then I do search, and I shouldn't find Bob, but I do because he's still there. Okay, because only one of them has been deleted, and that again creates anomalies. And those could be more serious than simply having data left over in the database. It could be that products are sent to the wrong addresses, bank accounts aren't working correctly, so it can be incredibly difficult. Data consistency then is kind of like the follow-on from that, because consistency in a database is really important. We don't want an important database like your bank details, your bank accounts, or your shopping history on Amazon to be inconsistent, because if it is, then things will start to go wrong with really important things like your money. Okay, so if you have a bank account and there's no consistency in that database, and there's these update anomalies and delete anomalies and all that kind of stuff, there's a potential for money to go missing. Now that can't happen, because if it does happen, people get very cross about it, and people start to sue and make claims and things like that. So banks can't afford to do that. So they make enough mistakes without that. So data consistency is really important. So when a row is changed, all rows with that same data must be also changed. So if we have to do that, then that is difficult, because there's a chance we might miss one, or we might not update one. And it creates a lot of effort on part of the coder. And coders, although we are superhuman, obviously, we do make mistakes. And a lot of bugs that we see is when a coder makes a mistake. And because code is so complex nowadays, it's so easy to make these mistakes. So we don't want to have our database structure done in such a way that those mistakes can happen. Okay, we want to remove those, and therefore we normalize the database. So do make notes on this. I've included these two links, and I'll put them in the description on the in YouTube as well for you guys. They're great ones to go over the basics. So the first one explains why we do normalization. The second one actually goes through the normalization steps. So the second one has links to other YouTube videos which I found quite useful, and other students in the past have found quite useful. It's not really aimed at sixth formers, but I found it one of the more accessible ones for students. There's lots of information about normalization out there, but I don't feel that every single one of them is accessible to sixth form students. Obviously, feel free to do your own independent research on this. If you do find a better website, please let me know, because genuinely I would be interested in it, because this is a topic where a lot of students find it difficult. Okay, so I hope that was useful, and my next video will be actually going through and actually do normalization.